Hello everyone, once again we are learning and we are still at home, and today we are going to look at factors that affect preferential discharge at the electrode and also at the cathode and also at the anode. In our previous lessons, one of the lessons we already looked at one of the factors, which is the position in the electrochemical series. Number one is position in the electrochemical series. Number two is the concentration of ions. And number three is the nature of electrons. So, position in the electrochemical series we have already looked at in our previous lesson, where we wrote the electrochemical series for both cations and the anions. And we said if it is lower in the electrochemical series, it will be easy for it to accept electrons, and if it is higher on the anions series, then it will be very easy for it to lose electrons. So the position, one of the factors is the position in the electrochemical series, and we have already looked at that in our previous lesson, where we were looking at the electrolysis of aqueous or sodium chloride solution. It was dilute. It is important to note that it was dilute sodium chloride solution. Is one of the examples that shows how the position in the electrochemical series affects the preferential discharge at the electrodes. We go to the next one, which is concentration of ions. We are still going to use our example. You still use our example of sodium chloride. Now, in the previous one, we looked at dilute sodium chloride, and we discovered that the position of sodium, it is very high on that reactive electrochemical series, and hydrogen ions being very low will be preferentially discharged. And when we came to the anions, we discovered that OH ions are higher than the chloride ions. They are higher than the chloride ions. And the OH ions are going to be preferentially discharged. They will be preferentially discharged, and the chloride ions are not going to be discharged in dilute sodium chloride. What if we make the sodium chloride more concentrated? And the other name for concentrated sodium chloride is brine. Brine, you also come across it when you are looking at solvent process. Brine is concentrated sodium chloride. So when we make it concentrated, what that means is that we are increasing the number of sodium ions, and we are also increasing the number of chloride ions in that solution. When we increase the number of sodium ions, and we also increase the number of the chloride ions in that solution, we will discover that at the anode, chloride ions will be discharged. Why will they be discharged? Because there are many in that solution. The concentration there is very, very high. Now, at the cathode, we say that sodium ions and the OH and the hydrogen ions are going to migrate there. But when you look at the gap between sodium ions and the hydrogen ions on the reactivity series, the sodium ions, and the we have magnesium here in between, we have aluminium, we have zinc, iron, and when you look at the gap, there are some few that I've left out here. When you look at the gap between sodium ions and the hydrogen ions, as much as the sodium ions are concentrated, hydrogen ions are still going to be preferentially discharged because the gap is too big. It also it requires a lot of energy for sodium ions to accept this one electron compared to hydrogen ions that are present in this solution. As much as the number here is high, because we are talking about it being concentrated, it is true the number of sodium ions are high and the number of hydrogen ions are less, but the amount of energy that will be required for this one to accept an electron is quite high compared to that energy that would be required for hydrogen to accept that electron. That means that this hydrogen ion is still going to accept an electron and leave the sodium ions in the solution as much as their concentration is high. But when you come to this, the anions, remember I said that for anions we say that I bought iodide, bromide, I bought cabbage, chloride, not sausage for the sulfate, or I bought cabbage, not sausage. So when you look at these anions, the position of the chloride ions compared to that of the OH ions, there are only two. There are only two ions that are separating there. The gap is so small. The gap is so small. So the concentration of the chloride ions in that solution will overtake. It will overtake the preferential discharge, or this one will not be discharged because the concentration here is low. The number of hydroxide ions in that solution are very low. But this one is very high. It is very high, and this one will be preferentially discharged at the anode. So let us write those two equations and see what happens to the concentration also, or what happens to that solution. What happens to that solution? So we have said at the cathode, hydrogen will still be discharged because it requires less energy for it to accept. Plus 2 electrons, we get hydrogen gas. This is AQ. And then at the anode, as much as the OH is present, the number of chloride ions in that solution is very high. It's very, very high. So chlorine will be discharged. Chlorine will be discharged, or the chloride ions are going to be discharged. So at the cathode we will have hydrogen being discharged, and at the anode we shall have chlorine being discharged. One of the precautions for this experiment must be carried out in a fume chamber. Chlorine is a poisonous gas. So it is either in the fume chamber or in the open. So in this whole process of electrolysis of brine, it's like we are removing the hydrogen ions and the chloride ions from the solution. And we are being left out with sodium ions and the OH ions. Sodium ions and the OH ions. So what happens to the pH? What happens to the pH of this solution? We are left with a solution, sodium hydroxide solution. We know that sodium hydroxide solution is a strong base. It is a strong base. So the pH of this solution, remember Sodium chloride is neutral. Sodium chloride is neutral. So it will have a pH of 7. So as the electrolysis goes on, the pH will increase. It will increase towards 14. The pH increases towards 14 because we know sodium hydroxide is a strong base. So in our next lesson, we shall look at the nature of electrode as a factor that will affect the preferential discharge of ions at the electrodes. Thank you. Let's meet in our next lesson.